Hello again, everybody. So I wanted to show you the latest iteration of my Coco bus interface board. So this is another prototype. The final version is going to look very similar to this, except what I've decided to do is I've been able to strip down the part count so that there's really just the one large CPLD that does all the logic, and a single memory chip that covers the ROM as well as register buffers. And the rest of this is just kind of like just connection stuff, the JTAG connector. And probably the biggest innovation that I've done since the last time is, if you'll recall from some of my earlier things, there's a whole 40-pin header over here to connect, and it does a parallel interface. I switched to a larger CPLD that allows me to use a serial interface. So this is kind of a standard SPI interface, as well as a pin that essentially acts as an interrupt to the microcontroller. If the Coco writes to memory register, the pin will go high so that the microcontroller knows that it needs to do a read and figure out what just changed and so forth. So the next board I'm going to make is actually going to be a refinement of this one, but it's going to be hopefully a bit smaller and much smaller chip count. So what I did to actually get this logic squared away is I used my bus buffer board that I showed a little while ago, and I've got it here connected to the DE1 Altera FPGA board. And I'm essentially prototyping all of the code that I'm ultimately going to put on the CPLD on this FPGA, and using its SRAM instead of the SRAM that I would have on the board. So the good news is that I've got all of the bits and parts working, the code works, and I'm going to be able to dump it into the CPLD because it's still small enough. So as this demo, as I usually do, I've got Dungeons & Daggerwrath up here. It's running off of the SRAM that's on this board. And what's new is, number one, because I'm going to have a separate clock on the CPLD, that allows me to essentially time slice the SRAM access, which means the Coco thinks that it's talking at full speed with the memory and pulling all of this stuff off of the ROM, but the serial interface can interact with it at the same time. So I obviously can't overwrite the ROM, otherwise it'll get very unhappy, but I'm going to run a quick verification routine here. So I'm going to say verify that the Dungeons & Daggerwrath ROM map is correct, and it walking the memory, it verified complete. I'm going to run that again, and you can see the Coco is doing its thing at the same time, and it can do that because it's essentially buffering a little bit of magic inside the FPGA board, and ultimately I've got the same logic working on a CPLD. So this prototype, we've got a couple of things I can show you. So number one, this big pile of wires is really just because I didn't want to mangle anything. So it's connecting, and this is essentially the SPI interface. It's just the serial interface and ground line and that interrupt line. And the interrupt line is going into one of the digital inputs on this mega board here. I've also wired up another input, or another output, excuse me, to this little LED. So I'm going to actually shut the Coco off. I'm going to tell it not to boot. That's basically the CTS, the ROM boot switch. So it's just going to boot kind of normally. But what this allows me to do now, it's still connected. Now I can actually interact with it as if it's a peripheral, and I can demo some of the peripheral stuff. So this has this idea of, okay, here is a little register dump. So it's dumping out FF40, 41, 42, and 43, I think. So what I'm going to do is I'm going to poke 45 into FF40. Now, you didn't see this turn on, but the LED over here is on, and that's because I told the microcontroller, hey, if you get a change indicator from the board that the register changed, and 40 is below, it's basically the 80 hex or below, light the light. Hex 45 is below 80, and there you go. I also have this on the microcontroller, and I'm saying just dump out the answers here, and you can see 45 is in that first location. I can also do a peek. And there you go, 69 is hex 45. So that gives you a flavor of this. Now, the next step, obviously, is going to be taking this prototype, dumping it onto a board similar to this guy, and then, and probably I'm going to start working on this very soon, building code for the AVR microcontroller, the mega board here, to not just do the ROM programming piece and this kind of demo register stuff, but I can actually start writing code that emulates floppy interface through those registers, or a bunch of other things. I haven't really figured it out beyond the floppy drive controller. And then the hope is that this same SD card that has the ROM images could have a directory for floppy images, and you could do the same sort of thing. You could have a logical kind of navigation of which floppy disk is in the drive, and then the interactions between the bus interfaces will kind of take care of all that. So that's kind of where I am. I'm going to get this hardware working, and then when it's fully cooked, I'll release it. Again, just like the other ones, the designs are going to be open hardware, and I'll probably start manufacturing. And once I got all the kinks out, I will offer these boards up for sale. So more news when I got it, but hopefully you enjoyed the demo.